graphing parabolas today, and we're going to spend several days talking about these. So tell me something about the equation of a parabola. What does it look like? How do you know it's a parabola when you just look at the equation? What? That's going to be a hyperbola when we have the x times y, and we've been having those in the first and third quadrants. That is another one of our conic sections. But what about parabolas? We've been punching some of these in on calculators. We've been talking about how they're related to other equations, Jack. They've got an x squared, and is y also squared or not? So what makes it a parabola is y is not squared, but x is squared. And then it's going to be some sort of a parabola. And we've seen on our calculators, sometimes they open up and sometimes they open down, depending on the equation. So these would all be parabolas, right? Because they've got an x squared in there. Even the ones down lower, if I FOILed out those parentheses, I'd get an x squared, right? Same thing as I keep going down the list. Okay, I've punched several of these into my calculator just so we can kind of take a look at, well, if we put numbers in different places, what does that do to where the parabola is in the coordinate plane? So here's my graphing calculator. And if you look at this graph here on the right, the black one is just the basic y equals x squared. And the red one, I put a +1 out here at the end. And point, which way did it move from the black one to the red one? It moved up 1, right? So this, if I had this +1 on the outside, it went up 1. That moved the vertex, the y coordinate, up 1. And let's see, on my next page now, the black is still x squared, but now I have x squared minus 1. And which way did that move when I put a -1 at the end? So it's looking like this +1 at the end moved it up, and the minus moves it down, and by however many that number happens to be. So if I did a +5 out here, which way do you think it would move? If I had a plus, I've seen fingers pointing up, and how many up if I had a +5? It would move it up 5, and so on. Let's see what happens if I put the plus and the minus inside the parentheses before I square it. So again, the black's the original. The pink or purple or fuchsia or whatever we want to call that color is x plus 1 squared. Point, which way did that move? That seems a little bit backwards, but you're right, that is what it's looking like when I look there. When I do the +1 on the inside, it went left, it went in the negative direction. And prediction on the next one? It's going to go to the right. So you see that on the green one. So we're seeing if we have a number on the outside, that tells us it goes up or down that many. So that's changing the y coordinates of everything on the parabola, but especially the vertex. This one moved the y coordinate up 1. This moved the y coordinate down 1. When it was on the inside, it moved it side to side. When we had the +1, it went left 1, the opposite way. It moved that vertex 1 to the left or 1 to the right. And I'll do one more for the time being here. Let's try this -3 squared -5. I think that's what I typed in here. Yeah, so the black one's the original one. I had a -3 on the inside and a -5 on the outside. We saw the plus or minus on the outside, moved it up or down. Does this look like this orangish one went down 5? And does it also look like, let's see, the opposite way? It was a -3. Does it look like it went to the positive direction, to the right 3? So what I had was my original one had a vertex of 0, 0. And this new one, I moved it over. It went 3 to the right, so now the x coordinate of the vertex is 3. And the y coordinate is now a -5. but it moved down to the -5. Does that much make sense? So it's looking like if y equals a parentheses squared plus or minus something, the vertex of that parabola is going to be the opposite of what you see inside the parentheses. You saw a -3 and the vertex has a +3, but the same as what you see on the outside. So we're going to start with that much on our list. We're going to skip these first two lines for now. If we have y equals something or other with a parentheses squared plus or minus something, then the coordinates of the vertex will be the opposite of what's on the inside and the same as what's on the outside. Now, we've also been doing some of these on our calculators, and sometimes we've had numbers in front of the x squared. We've had 3x squared and a half x squared and -5x squared. Anybody happen to want to make a guess of what happens if I have a positive number in front of x squared or a negative number in front of x squared? What difference that might make? Wyatt? So y equals x squared opens up, but if we put a minus any kind of negative number in front of it, it's going to open down. So if a is positive, the parabola opens up. And if it's negative, the parabola opens down. And I am going to come back to the slide, so if you haven't finished, don't worry. But let me go back to my calculator. And I've also got some where we have that going on. So the black one is y equals x squared. The red one is y equals 2x squared. It got steeper. The blue one is y equals a third x squared. It's not as steep, but all three of those had positive things out in front, and they still opened up. And the red and the green ones, the red one is minus x squared or minus 1x squared. The green one is minus 5x squared. So you see, you guys were correct. Those minus signs make them open down. And we could go ahead and put that much in our formula list right now. I'll need to talk about that axis of symmetry in there. So just to have this in that formula list where it's easy in 6 weeks to find it if you need it for some reason. This says the vertex is the opposite of what's on the inside and the same as what's on the outside. Axis of symmetry, whenever you have a parabola, whether it opens up or down, can you see and do you remember that the left and the right are mirror images of each other? That we can draw a line right down the middle and we could fold it in half and the left and right sides would match up. Are you with me on that? That's all we mean by the axis of symmetry. It is the line we could draw right down through the middle of it so that the left and the right halves match up. It is a vertical line. It is not a point. So it's not just a number. It is x equals, because it's vertical. Y equals are horizontals, x equals are verticals. If you look at this parabola, here's the vertex, HK. Does this point have the same x coordinate as the vertex? Yes, no? What about this point up here? All of these green points that I'm drawing on here, do all of those have the same x coordinate, the same as the vertex? So that means the x coordinate is h for every single one of those points. That's why the axis of symmetry is x equals whatever that coordinate was. We are also going to be talking about x and y intercepts, but we've already been doing that. The y-intercept is going to be 0, something. The x-intercepts are something, 0. Anybody still copying things from this slide? Okay, so we want to go back to this page and fill in a little bit more. So we've just noticed that the axis of symmetry would have to be x equals whatever the x coordinate of the vertex is. And we know from other problems when we find the y-intercept, we set x equal to 0 because it has to be 0 comma something, and then we solve for y. And to get the x-intercepts, we set y equals 0 and solve that for x. Sometimes when we're solving for x-intercepts, we'll get nice numbers, and sometimes not so nice. And then the next section of your notes talks about the discriminant in there. Anybody need me to wait before I go to that part? So our discriminant is just the b squared minus 4ac out of the quadratic formula. And we have already been making connections on problem sets when we have had parabolas and explain why the graph does not cross the x-axis. Notice the connection between the x-intercepts and the solutions you got when you solve the related quadratic another way. We're kind of going to go a little bit the other way. Let's start with that bottom one. The graph has no x-intercepts. When you had those on problem sets, what did you write for an explanation? Explain why this graph has no x-intercepts. What kinds of things were you writing when you had those show up? Kip? Okay, so we got only complex numbers, complex solutions when we had no x-intercepts, right? Okay, think about the quadratic formula. When do you get complex answers with this discriminant? What have we been saying on that, right? If we get a negative for b squared minus 4ac, that means we're taking the square root of a negative. So that means we're going to have complex, and that's when we have no x-intercepts. So if we have no x-intercepts, we can say that the discriminant is negative without even having to do the calculations, without having to find out negative what, but it's got to be something negative. What happened when the discriminant was positive? What have you been saying on these most recent homework sets? You got a positive discriminant. What does that mean about your solutions? Somebody who has not answered yet. Abby, thanks. If the discriminant is positive, so you're taking the square root of a positive number. So your quadratic formula is the opposite of b plus or minus positive over 2a. How many answers are you getting in that case, Nicole? And are they real or complex? And when you have two real solutions, think back to even earlier problem sets. You worked through, I don't know, maybe you factored it and got two real numbers. How did those two numbers relate to your x-intercepts when you graphed it on your calculator? Ethan? Well, the parabola crossed, but what about the coordinates where they crossed? What if I factored and I got x is 2 and x is 3? What numbers did the parabola cross the x-axis at, Cooper? It'd be those exact same two answers. So if I have two real answers, then the parabola crosses at those same two real numbers. So if it crosses at two places, that means that the discriminant is positive because we have two real solutions. What if for this middle one, the vertex is on the x-axis? What does that mean, Yesenia? The discriminant was 0 because we have the opposite of b plus 0, the opposite of b minus 0. we get the same number right there. So that means that the discriminant is 0. And when you are doing homework problems, we have tried to add in typed little prompts of, does it open up or down? What's the vertex? What's the axis of symmetry? What's the y-intercept? What are the x-intercepts, if there are any? And is a discriminant? And you just write positive, negative, or 0. We've tried to write prompts for now, but you answer all of these things regardless of whether we taught it and got those prompts typed in for you or not. So when you are doing these, we're going to try to give you the prompts. You need to identify all of those things. That's what I just talked about. We'll try to have the prompts. And in addition, plot at least 5 points. Okay, let's model that. I think this matches your example 1, right? Is that the same equation that you have? So we're going to look in front here. Is that positive or negative? So everybody, is it open up or down? Because it's already in this form, we're going to look at it and write down the x and y coordinates of the vertex. Opposite of what's inside, same as what's outside. So Griff, what's going to be my vertex? Opposite of what you see inside, same as what you see outside. So -1, -2 is going to be my vertex. So -1, -2 would be right about there. And it's going to open up. And my axis of symmetry needs to go through that vertex. So what is my equation of the axis of symmetry? Yo-Yo, you want to help me with that? What's the equation of that vertical line that I just drew going through -1, -2? X, and what is H on this one? What is the X coordinate of my vertex? -1. Now, I will count this wrong if you write -1. It's got to be X equals -1. The axis is not a number. The axis is not a point. The axis is a line. So you've got to have the X equals for the vertical line, Y equals its horizontal. Okay, right now, before I even draw it, and I'll erase this part because I don't know how fat or skinny to make it, I know it opens up. So how many x-intercepts will I have? 2. And if I have 2 x-intercepts, will my discriminant be positive, negative, or 0? Look at your page if you need to. If I have 2 x-intercepts, will the discriminant be positive, negative, or 0? Cooper? So we can say that the discriminant will be positive. To find the x and y intercepts, we need to plug in x equals 0, y equals 0, and solve. We wrote that step down, so let's get the y-intercept first. That means x is going to be 0, and we want to find what y is. Show whatever work you have to do to calculate that. I'm coming up to my equation. Y equals 0 plus 1 in the parentheses. What's that? 1, and then I need to square the parentheses. What's 1 minus 2? -1, so my y-intercept is -1, or 0, -1. And with the intercepts, I need 2 coordinates. So let's plot 0, -1. Most of the time, we can do a reflection of that to get a third point. Right now, I've got 2 dots for the parabola. But because this line of symmetry, this axis goes through the middle, I need the reflection on that other side. So I go straight from this point to the axis. That was 1 box. So then I go 1 box on the other side and draw another dot. Maybe my x-intercepts will be nice points, and I get that, and I can plot those, and I have my 5 points. Or maybe they'll have square roots in them and not be so nice, and I'll need 2 others. So let's see what the x-intercepts are next. For the x-intercepts, we know we've got 2 of them, something comma 0 and something comma 0. So I'm going to let the y be 0. So I have 0 is my parentheses x plus 1 squared minus 2. I'm going to try to get parentheses squared equals. So if I add the 2 to both sides, I have that. Kind of like with completing the square, how do I undo the square? Square root of both sides, but with the plus or minus, which means I have x plus 1 is plus or minus root 2. So what do I do to have that be just x? Subtract 1. So I have one of my x-intercepts is -1 minus root 2 comma 0, and the other one is -1 plus root 2 comma 0. Are those easy to plot? Not for me anyway, so I'm not going to use those as my fourth and fifth point. I'm going to do an XY table to try to come up with something else. So I have x is -2, x is -1, x is 0 for these. So I can pick something else. I could pick 1. I could pick 2. Don't want to go too far or I'll get something off the grid. But if I pick 2, what's 2 plus 1? 3. And then I need to square that and subtract 2. So what do I get? So I'm going to plot 1, 2, 1, 2, 3, 4, 5, 6, 7. Now I've got 4 points on there. To get a fifth, I'm going to go straight to the axis. That was 3 boxes. So now I'm going to go 3 boxes past it and do another dot. And then I'm going to draw a smooth parabola in between and put arrows on both ends. And they get faster the more of them you do. I know that one was kind of slow because it was the first one of these we've done. Anybody with a question there? And we'll be good to go on to example 2. All right, so which way does this open? Everybody, point up or down for me. So this one's going to open down. I want you on your paper, write down what you think the vertex is. Opposite of what's on the inside, same as what's on the outside. Allie, what did you write down for the vertex? Thumbs up, thumbs down. So that means 1, 2, 3, 1, 2. And it's going to open down. How many x-intercepts will that have? Don't draw it yet. 2. If it has 2 x-intercepts, what does that mean about the discriminant? Positive. I should have undone that parabola that I drew real fast first. Now I'll write positive. Okay, my axis needs to go through that. So my axis needs to go through that vertex. So write down what you think the equation will be for the axis of symmetry. And Leo, what do you think the equation of that dotted vertical green line is? Thumbs up, thumbs down for x equals 3? Sounds good to me too. Now we're left with coming up with the x and y intercepts, and maybe those are all easy to plot, maybe not, but we need to end up with 5 points, and we already have the vertex as one of them. So y-intercept, we need to let x be 0. So you crunch out some work right now. Let that be 0. Y is a minus sign in front of that parentheses. 0 minus 3 on the inside. Square that and add 2. What is just the minus 3 times minus 3, everybody? 9. So that's a 9. So we have minus 9 plus 2 is -7 for that y-intercept. So we're going to plot that. 1, 2, 3, 4, 5, 6, 7. Can we get a reflection of that, a mirror image? 1, 2, 3, 1, 2, 3. For the x-intercepts, we need to have y is 0. We know there are two of them. So we go back to our equation, and now the y is 0. So 0 is minus x minus 3 squared plus 2. Okay, since this one has a minus in front of it, I'm going to add it to both sides and have x minus 3 squared is equal to 2. Austin, what should I do to get rid of the square on that parentheses? Square root, but if I do that, I've got to remember the plus or minus, just like in the completing the square method. So now I have x minus 3 is plus or minus root 2. What do I do to make that be just x? Ada, what do I do to make it be just x? So x is going to be 3 plus or minus root 2 for our x-intercepts. So we write those down. The one on the left is minus, or is, I'm sorry, is 3 minus root 2. And the one on the right is 3 plus root 2. Are those easy enough to plot to let those be our fourth and fifth points? I'm not good at plotting square root things. So we're going to do a table of values. And as I look at that, I already have a point with an x of 0 and an x of 3 and an x of 6. So I want something somewhere in between, and different people can choose different things. Personally, I kind of like 1. So if x is 1, let's come back up here and let's plug in. Let me erase some of that stuff that's kind of getting in our way here. So now I'm going to put a 1 in for this x. So I have minus 1 minus 3 squared plus 2. What's 1 minus 3? And negative 2 times negative 2 is, and then we have a minus 4 plus this 2 out here. So 1 minus 2. So 1 minus 2. And then that's 2 to the dotted line, 2 past it. And then we would draw our parabola in like this. Are we starting to get the idea of what we're doing? Madeline. Oh, so I got this one because it was the y-intercept. And then this axis of symmetry divides it into 2 equal halves. So I go to the center line, and because I went 3, I go 3 on the other side. If it had taken me 4 to get there, I'd go 4 on the other side. If I had one on the right and I went 3 to get to it, I'd go 3 to the other side, which is now the left, to get the other one. Just less algebra to crunch through. We can just say, oh, it has to match. Okay, these I won't take time to go through the whole thing, but everybody tell me, does this one open up or down? Up. And tell me what the vertex is on this one. Cooper? Is it 2 and 1? Well, let's see. We need the opposite of what we see on the inside is 2 the opposite of that. And the same as what we see outside. Do you see a plus 1 out here? So what do you want to change? That's a plus 0. So the vertex is 2, 0. So 2, 0. And I'm not going to take time to do all the accurate stuff, but somehow or another, that one's opening up. So how many points of the parabola are on the x-axis? How many x-intercepts do I have? Just 1. So the x-intercept is also that vertex. It's also 2, 0. And if I just have one x-intercept, is my discriminant positive, negative, or 0? The discriminant has to be 0. And I won't take time to do the other intercepts and finish the graph. For example 4, let's do the same kind of thing. Is it going to open up or down? And write down what you think the vertex will be. Caleb, what do you think the vertex will be? Opposite of what's inside, same as what's outside. So 1 and -1, how does that look to the rest of you guys? So if I go to 1, -1, and this one's going to open down, how many x-intercepts will I have? Everybody good? That one's not going to cross the x-axis. So we would write none when that happens. And does that mean the discriminant is positive, negative, or 0? Questions on anything we've talked about?